So hello and welcome to
Yes,
this video in my networking basics series. I'm Apurva, and today we'll talk about HTTP, the Hypertext Transfer Protocol. In the networking basics series of videos, and as you can see here, I have covered the complete IP stack. And to start with the very basics, we moved on to the Ethernet. Then we discussed about the IP protocol itself. We talked about UDP, TCP, ICMP, and in the last session we talked about DNS as well. So now we have reached the application layer today, and I wanted to talk about HTTP, which functions on that layer. So let's dive in. So let's have a quick look at the layer model of the internet, specifically the layer 3, the internet layer. Here we have the IP addresses and protocols like IP version 4 and IP version 6 that we use. Then on top of that, there is a transport layer, which mainly includes the UDP and the TCP. The purpose of the transport layer, as you know, is to provide flow control and other functions for reliable data transfer, congestion avoidance, and etc. Then above the transport layer, we have the application layer, which completely depends upon the transport layer, usually either using UDP or TCP as a transport protocol. And this layer contains the communication protocols and the interfaces used by the applications you use every day. So here all kinds of relationships are possible, client to client or client to server, server to server, or peer to peer. So there are many examples also, as you can see over here, that we have email where the protocol we use is as SMTP. Then we have HTTP as well, which we use for web browsing. Then we also have many more protocols for audio and video and other types of communications as well. So, but today, like I said, we are going to talk about HTTP. HTTP is nothing but it stands for Hypertext Transfer Protocol. So you might have seen that in your browser address bar, usually it starts with HTTP, or more often nowadays it's HTTPS. So HTTP is something we use constantly and everywhere. So however, the mostly used version that we use is the HTTPS. S stands for secure. And some people might think that there was no internet before HTTP or the web, but that's not true. The internet existed few decades before even the web and the HTTP also came around. So let me give you some example of what existed before HTTP. So one of the primary protocols was the file transfer protocol that we used. We were shifting files all around the world before HTTP using FTP protocol. So FTP is still around, although it's rarely used nowadays. It has existed since 1970s. And another significant protocol is the email. Email started in the 1980s and is one of the oldest protocols still running today. And it's been modified, but remains quite unchanged since the 1980s. And also in the 1990s, there was another protocol for documents called as the Gopher. Uh, I don't think so anybody would be remembering Gopher because it's a very old protocol, and even myself, I was not aware of this protocol, but people used to use that protocol back then. So Gopher had many of the disadvantages, one of which it was that it required a uh, license fee for the inventor, which was the University of Minnesota at that time. And surprisingly, there are still a few Gopher servers around still in existence. So you could check that out in Wikipedia for any more information about that. So uh, then the HTTP came along, bringing the web with it. So it was invented in the 1989 by Tim Berners-Lee at the CERN in Geneva, and the invention consisted of several parts. So as you can see here, the first part was the hypertext transfer protocol itself, that is the transfer protocol. And that then there is HTML, that is the page language that you know, the language used for creating the web pages. Then we have the web server, a server to host and serve those documents. And we have the web browser, a tool to view the served documents. So these four components collectively made up the web. HTTP 0.9 was the first version of the protocol and was documented in 1991 and became the first consumer-ready and usable web protocol. And since then, HTTP has evolved quite much. So what we still using today is the HTTP version 1.1, which was introduced in 1997. The development of HTTP involves several parties like the IETF, which is the Internet Engineering Task Force. They take care of the protocol itself. Then we have the W3C, W3C as well. I was talking about W3C. W3C is nothing but the Worldwide Web Consortium. So they take care of the page language, that is the HTML. And there were various companies, they have created their own web browsers, developed their own flavors of the protocol, which were later standardized. And the next evolution after HTTP 1 was the HTTPS, introduced in 1994. And HTTPS added security through the transport layer security, that is the TLS encryption. So nowadays, we have two versions of HTTP, that is the HTTP2 and HTTP3. So these versions aim for better speed and faster connectivity. I'll talk about that further in the presentation also. So how does HTTP work? So let's discuss about HTTP 1 because it is the easiest of the protocol and still used version to understand. When I refer to HTTP in this presentation, I mean HTTP 1. It is the most commonly used version and it is straightforward to understand how it works. So HTTP is a request response protocol, and the client such as web browser sends a request uh, wherein you receive a response which uh, can be a data like a website, image, or an error message. So importantly, you can see that HTTP is a stateless protocol, meaning each request and response stands on its own, and no memory of the past request is being saved. So if context is needed, it must be supplied with each request. So this stateless nature applies to the application layer, wherein the underlying TCP connection, however, can be used for multiple HTTP requests and responses. So you don't have to open and close the TCP connections repeatedly. So let's look at a typical HTTP.1 request and response. So this is an example of a response wherein, in this case, this is a get response, and there are other methods also that like head, post, and put. Then we have the request target over here. This specifies the resource such as a web page, or is often just a slash denotation. Then we have the protocol itself, that is HTTP 1. Then we have a header section also. This section is similar to the email headers, wherein with each header field consisting of a keyword and a colon and then the content to it. And we have the host header field also with it. Host header field also. This is also essential because multiple web servers can share the same IP addresses. And it tells the server which host the request is meant for. And there are also optional headers into it, wherein each request could include these headers, providing necessary context, and they must be included in every request due to the HTTP stateless nature. Let's look at a response header as well. As I have told you that there are several optional keywords over here, like the encoding is there. So yeah, so this is a response example. So it starts with HTTP 1.1, then we have a status code that indicates the result of the request. For example, 200 OK means that the request was successful. Then we have the uh, body also, wherein the body contains the actual content of the response, such as the HTML for the web page or an image. The body can be a plain text or encoded in various formats. For details of encoding, refer to any documentation. In the summary, HTTP transaction consists of requests and responses only, including the headers and an optional body. And the request specifies what the client actually wants, while the response provides the requested data or an error message if the request is not proper. Let's talk about HTTPS. So HTTP is just a plain text and not encrypted. So do you want to do your banking over that? Not really, right? So that's where the HTTPS comes into picture. So HTTP comes with several important features. First, you can be sure that the website that you are interacting with is indeed the one that it claims to be. So it's really your bank that you are typing your password into. Okay. And second, you don't want on the transport layer to anybody to be listening to your data. And third, that the information the web server sends is not tampered with, meaning that nobody should be able to change the values or alter with the text during the server uh, and client data transmission. So let's talk about transport layer security. So on top of HTTP, none of these security measures are possible. That's why we use another protocol in between that is called as the transport layer security. That is nothing but TLS. And remember that internet is built on layers of protocols, and TLS runs on TCP, making it the part of the transport layer. But HTTP runs on top of TLS, so making it a part of application layer as well. So this means we can stack the protocols together, creating a protocol stack. And that is the beauty of internet and the IP protocols, that they allow us this ability to layer the protocols on top of each other. So let's see how does this actually works. So remember the three-way handshake that we talked about in the IP presentation. So transport layer security is somewhat similar. So here is the breakdown for it. The first one being is the protocol version negotiation. So wherein both parties agree on which version of TLS they want to use. And then we have the cryptographic algorithms, wherein TLS supports multiple cryptographic algorithms. Uh, and both sides must agree on a common algorithm to communicate securely with each other. And then we have the authentication part. This is also a visible part of the HTTPS. It ensures that the website you are talking to is the one that you intend to talk to. And then we have the session setup, uh, wherein during this process a shared secret is established, which is a cryptographic key used to encrypt the communication. And this shared secret is actually calculated on a random data with a pre-shared secret, which is sent in an encrypted public server key. And this server public key is contained in its certificate only. So during the session setup, the server and the client communicate to establish this secure connection actually. So the nice thing about HTTP is that it's text-based. And what about HTTPS? So yes, there is also a way to test HTTP as well. So if you have a Linux or a Unix-based system, wherein you have an open library, open SSL library installed into the system, so you have a command line command that you have just showing you onto the slide, and it's also on the right hand side of the slide as well, where you can see uh, this command enables you to securely connect it to your HTTPS servers. Wherein if you are the host has an open SSL command, you can check that out as well. This command allows you to establish a HTTPS connection to perform the SSL handshake and to get the content actually. So in the example shown, you can see the decrypted form of the connection after the handshake gets completed, but it's not showing out here for some reason. Yeah, it's showing right now. So this is the output that I was talking about. So it's actually a video that is being played in the background, but this is the entire output. It's quite pretty large output, as you can see over here. So let's talk about some authentication and certificates. So like historically speaking, obtaining such a certificate was quite expensive and cumbersome at that time. So you often had to fax some documents like your passport to the certification authority and pay a substantial amount of fee, and then they would issue a certificate to your web server. So this complexity meant that HTTPS was mainly used by the entities that really needed it, such as bank and financial authorities. But nowadays it's much easier, and we get a free certificate. All you need to do is that prove that you are in control of the domain or the web server, and this typically involves placing some verification information on the web server. And once you complete this process, you can get a free certificate from the providers like we have Let's Encrypt. If you are interested to check out, you can also visit let'sencrypt.org for more details onto it. Like I said, historically, it was quite expensive, and nowadays we have some websites like let'sencrypt.org, which helps us to get a free certificate as well. So if HTTP2 is so complicated, uh, so you would must be thinking what are the benefits to it. So the primary goal of HTTP2 is optimization for speed, and instead of the traditional request and response pattern or of HTTP, it allows multiple streams between the client and server to communicate. So HTTP2 allows multiple stream, as you might think, and this means that the web page is full of images, and so you can request all of the images at once, which speeds up the loading time. And however, this also means that the messages you are messages are now binary rather than text based, which can also be a downside to it. So another significant feature of HTTP2 is a server push mechanism. So this allows the server to send some responses to the client proactively. For instance, if a client requests for a web page, and server can anticipate that the client will also request for the associated images next. So it sends them before even the clients ask for them. So I believe our audience is clear about the HTTP 1.1 and HTTP 2 up till now. There are no any confusions or any questions as of now, because this is fairly straightforward and simple up till now. As I talked about that HTTP2 is optimization for speed. We can use multiple streams. That is both good and bad, you can say. Like you can consider you can have a single TCP connection and have multiple threads going on with the same TCP connection, so that web page loading is also faster in HTTP2. So let's talk about HTTP3. So HTTP3 is an exciting development that represents a significant departure over its predecessors. Uh, while it maintains the same kind of information exchange between the previous version, it no longer uses TCP. Instead, uses HTTP3 uses QUIC. QUIC operates, as you can see in this diagram as well, that QUIC operates on the top of UDP, and the primary goal of QUIC is to enhance speed, particularly speeding up the session setup actually. So how does the protocol stack for the HTTP3 looks like? As you can see here, over in the UDP, on top of UDP, there's QUIC. QUIC is technically a layer 4 protocol, but it functions on layer 5 as well. So HTTP3 sits on top of QUIC, and one of the standout feature that you can talk about QUIC, that it supports transport layer security as a built-in feature. So this means that there is no need of a separate TLS layer, and so it streamlines the process. And like you can see in the traditional HTTP and HTTP2, you first need to have a TCP connection, then the three-way handshake, then followed by a TLS handshake, and before you can start exchanging any sort of data in HTTP and HTTP2. But QUIC combines all of these three steps into one, making the session setup much faster. And additionally, QUIC uses different algorithms for rate adaptation and data transmission as well, which further enhances the performance also. So although QUIC is a quite complex and beyond the scope of the discussion, it's important to note that HTTP3 is still running on QUIC, and UDP represents a significant advancements where in the web protocol technology, wherein QUIC and UDP work hand in hand to give us these features. So if somehow you notice that a lot of UDP traffic is going on to your websites, and if you do a packet capture also, and if you see that a huge amount of UDP traffic is being seen on a particular website when you are browsing or downloading some stuff, so it likely indicates that it's using HTTP3 with QUIC. So let's come to our conclusion slide for HTTP and HTTPS. So like I said, that HTTP is a stateless protocol, and uses port 80 by default. It handles the request and the responses, but doesn't retain any sort of information about the previous interactions. Then we have HTTPS, wherein we use the port number 443, and it adds encryption authentication to ensure security, and it also verifies the authenticity of the website and protects the data from being tampered or being intercepted. Then we have HTTP2. HTTP2 enhances the speed by allowing multiple streams over a single TCP connection and introduces server push capabilities also. Then we have HTTP3, which utilizes quick over UDP and instead of TCP, making connections faster and mandatory encryption also. So if you want to check out any more further information on this, you can explore the documentation on Wikipedia or the original RFCs also, which are present online. So that was it from my side. So I thank you all for this attending this session. Anyone from the audience, if they have any questions, please feel free to ask. Because today's topic was a straightforward topics, and we were just touching the basics of it. So what is Quick? Quick is nothing but a protocol that I said. No, it works on layer 5. It's top on UDP. It's a protocol itself. It just helps to speed up the connection faster. The three-way handshake, then the TLS encryption, plus everything that gets sorted in one single session itself, so that whenever you access that website which is using a quick on the HTTP3, the data access is faster. So many of the websites today usually support HTTP3 as it uses UDP, and usually UDP is a stateless, so it's rather fast in communication.
Apurva,
Yeah, Suresh.
could, could you please check your chat box? Few of our attendees have an queries.
UDP will not get acknowledgement. It's port 80. Port 80 is for HTTP actually. For HTTPS, we any which ways we use port 443. That's the TCP port. How the certificates are installed in HTTPS. For instance, I'll take talk about a simple example wherein, like you are having a CRM portal, wherein it's space your web server might be only using HTTP certificate at that point, because by default we only have an HTTP port 80 certificate assigned to it. And then if you want to have your website secured, so you take a free SSL certificate or you buy an SSL certificate to encrypt your website. So you have some pre-shared keys which you give to your site admin or the one who is handling to your web server. So it binds those pre-shared keys with which in turn communicates and authenticates, so that whenever a customers try to access your web server, it automatically has those built-in certificates in his browser and communicates with the web server, so that the connection is a secure connection established. So someone is asking what is the 500 internal server error responses codes in HTTP. So HTTP itself is a vast topic to cover. We are just going on the basic level because there are many different types of error codes and things pertaining to the web servers. But this is a general discussion. So on the IP level stack, so that our audience knows why we are using DNS, like we discussed in the last topic, and why we are using HTTP. So to brush up on the basics, how HTTP functions, we had this topic. So we have to look into the error codes for the HTTPs in for the RFCs only. So that's a deep level topic to cover up in this session actually. I'll just sum up this session for you guys. So thank you all for attending this session. We truly appreciate your time and participation, and I hope you enjoyed today's content. And we invite you to follow our social media pages as well for any updates on our upcoming sessions and events. And additionally, you can visit our website for more information about our services and its benefits. So don't miss out on any future sessions and updates. Once again, thank you for your time, and we look forward to see you again at the next session. And so the next session will be on BGP, not in-depth BGP, but still it's an advanced level topic for intermediary. So we would be covering two topics next month on BGP. So let's see how it goes. I thank everyone for attending this session. Thank you.
Thank you for watching.